Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
I'm Celeste. For math homework help, call in Bakersfield 66-4357. Everywhere else, 1-866-66-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
Nicely done, Celeste. Thanks for taking care of that for Scott. I know he greatly appreciates that.
Absolutely.
So, Celeste, where do you attend school?
I attend school at Panama Elementary.
And what grade are you in?
6th grade.
You like 6th grade?
Yeah, it's fun.
Have you been to Camp Keep yet this year, or are you going? Do you know?
Yes, we're supposed to go in February.
Oh, good. So that's coming up. Have you started studying anything about that yet, or is it going to,
No.
as you get closer, I'm sure you guys will hit a little lot.
Yeah.
I know a lot of schools do it like that. So how is 6th grade overall?
6th grade is fun, a little challenging.
What's challenging about it?
Mostly how we have to do a lot of tests and a lot of one-pagers.
Okay. But you're all right with them
Yeah,
overall? What's your favorite thing about 6th grade?
maybe all the programs, like the music programs, the art programs.
Oh, so you like all of that. Do you participate in the music and stuff like that? You like
Yeah.
doing the art? You have an art instructor that comes to school?
Yeah.
Oh, good. Is there a type of art that you like doing more than others, or something that you've enjoyed doing so far this year?
I think I like doing where usually they tell us something to draw and we're supposed to draw it too.
Okay.
So they just show it on the screen and we're kind of supposed to trace it kind of from our memory.
So is there a type of medium that you like? So maybe like colored pencils, paints, markers?
I like colored pencils more.
So you like colored pencils?
Or crayons.
Okay. So you're comfortable with those?
Yeah.
Well, good. How's math going?
Math is, I'm getting good grades. Math is kind of easy, but in some, it could be a tiny bit challenging.
Well, that's what it's supposed to be, right?
Yeah.
Because where will you be going to school next year?
Junior high.
Right. And it's going to be a little more difficult than it is right now, right?
Yes.
So you need to get yourself ready for junior high, which is why you need those little challenges every once in a while, right?
Yeah, and all the like state tests and stuff.
All right, well, you know what? As long as you're comfortable doing them and you don't get too nervous, you'll be fine with everything. Are you ready for a little challenge right now? That's exactly what I want you to hear. So right now we're going to take a look at today's social media problem of the day. You ready? All right, let's take a look at it together up here. It says, convert this mixed number to a decimal. So when you see that, do you first of all know what mixed number means?
Yes.
What does that mean?
It's technically a number with a fraction attached to it.
Okay, so what number up there is the mixed number?
8 4/5.
Good, and what do we need to do with it?
We need to convert it to a decimal.
All right, so first of all, are all of our options in decimal form?
Yes.
All right, so now we're stuck. We have all 4 options that are in decimal form, right?
Yeah.
So now we
Can't
need to
rule
figure
any
out
of them out.
which one is the right one. So how do you want to approach this?
Maybe breaking down the mixed number.
All right, so explain to me what we'd like to do first.
So we know the whole number would be 8,
Okay,
and if we have to get the 4/5, we need to look at the denominator,
and which one is the denominator?
the 5.
Okay, so if the 5 is the denominator, what's the 4?
The 4 is the numerator.
Excellent vocabulary. What's next?
We have to put those two together to form that decimal.
Okay, so you mean 9? If I put it together, 4 and 5, if I put together?
No.
Okay, what do I do then?
We gotta have that whole number as the whole number in the decimal and take the denominator to put it as the 10th.
Okay, so explain to me what we want to do now. So we're going to go 4/5 and we're going to turn that into something else?
Yes.
What will we turn it into?
Maybe like a 0.5.
We could, right? So 4/5, think about that as, let's get something equivalent to it, right? So 4/5. If somebody said you had 4/5, do you know what percent that would be?
Like 99%?
It's close, right? But if we had 4/5, think about what would be equal to something over 10. So if we went from 5 to 10 in the denominator, what did we do?
We times it by 2.
Right, so we have to do the same thing to the numerator, right?
Yes.
So if we go 4 times 2, what would we get?
8.
So it would be really 8/10. Does that make sense?
Yes.
So 4/5 and 8/10 would be equivalent. Do you agree with that? All right. So if we have 8/10, and we know that's the same as 4/5, do you think we can find one of the answers now?
Yes.
Which one do you think it is?
8.8.
8.8? So you're thinking it's D.
Yes.
8 and 8/10, which is 8.8.
Yes.
You're feeling really good about it. Or are you feeling good about it right now?
I'm still trying to like process it.
Okay, well, let's process it just for a quick another second, all right? So do you think 8.5 could be the answer?
It can either be that one or D.
Okay, so you think it's either A or D. Why is it not B?
B because the whole number is a 9.
Okay, so we know the whole number here is 8. And if the other part was, let's say, top heavy, we would have to turn it and then we would get a 9 and something else, right?
Yeah.
But we know B is out of the question. What about C? Why isn't that one good?
See, there is no 2 in the thing, and you really can't make that the point 2.
Okay, well, there's no 8 in it either, is there? Other than the whole number 8.
Yeah.
I'm just following your logic there, sister. That's all we're doing, all right? So we're going to eliminate B and C. So you think it's A or D. And A, you're thinking 5 because it has a 5 in the numerator, or the denominator, I mean, right?
Yeah.
Okay. So 8.5 would be 8.5. Is 4/5 1/2?
No.
So
It would be D.
so it is D.
Yeah.
So you're now confident that it's D.
Yes.
We've wiped away the A. You're sure? Let's take a look and see if D is indeed correct. There you go. Nicely done. First problem all set. All right. Feel pretty good about that one?
Yes.
There you go. See, and that's just a process of elimination, and that's kind of a little bit of error analysis, figuring out which one doesn't belong to make it a little bit easier to
Rule
see
out all
which
the
one
other ones.
is correct, right? And you went through all of them, and that's exactly what you need to do sometimes. All right. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Big day today. You know it's a big day today?
No.
Because you're here.
Oh.
And it's a bigger day today because today is the first day that we're giving out tickets to Holiday Lights at Com. So that is happening today, tomorrow, as well as next week, Tuesday and Wednesday. All you have to do is phone in to do the math, have Scott or one of the other tutors, we work on your math problem, on the show. You will be going to Com to see Holiday Lights for free, simply for working out one of your math problems. Even if you're pretty confident in what you're doing, and you just want to verify that what you're doing is correct.
Yeah.
That's what we're here for also. So you could go home tomorrow, call us on Do the Math, right? And then you're going to get yourself some Holiday Lights at Com. Sound good?
Yeah.
Have you ever been there?
Yes.
That's pretty nice, isn't it? All right. Well, you know what? Time now for today's Math in the News. All right, today's Math in the News has to do with Polar Night, since we are in December now, and Polar Night is starting. And a lot of you might be going, well, I'm sure I've heard of this, but I'm not really exactly sure what Polar Night means. So let's take a look at what Polar Night means. So a polar night occurs in the circles, the Arctic and Antarctic circles. It depends upon the time of the year, though, all right? So right now, parts of Alaska will experience polar night for approximately 2 months. So about 65 days, parts of Alaska will experience polar night, as well as other parts of the world that are in the Arctic Circle. So the sun doesn't rise during a polar night, but you will still see some light due to the refracting over the horizon in what is called a polar twilight. Here we can see some of the math in here, and you can see that Earth quite nicely is on a tilt of about 23 degrees. Being our 23rd season, it's nice that it is 23 degrees. And, oh, today is our 23rd show. You know what? And we always love 23 here on the show. Why? because we all love Donnie. And those of you that have seen any episode before, you'll know why we do that. But anyway, let's get back to the polar night. So right now, we are in the winter solstice happening where the North Pole, you can see, is going to be affected. When we take a look at 90 degrees, if you're looking straight down at the Earth, 90 degrees is where the North Pole is. At the 66th degree latitude, now there's a difference between latitude and longitude. Think about changes in attitude, changes in latitude, right? One of those songs by Jimmy Buffett. So you're just kind of chilling, right? Based on your latitude or where you are in the Earth. So if you're closer to the equator, that's the 0, okay? At 66 degrees, all the way around the North Pole, all of these parts of these different countries will be experiencing polar night. And that is happening right now for approximately 65 days. On to moon phases. So this also has to do with the polar night as well. And a lot of people are used to seeing the phases of the moon, but may not be clear on the difference between a waxing moon and a waning moon. A waxing moon is getting larger. Waning is going away, it is getting smaller. So a waxing moon is getting larger, increasing in size, as opposed to a waning, which is decreasing in size. And we can see the different phases of the moon right here as the moon goes around the Earth. And the new moon, you're not able to see it at all. Some people go, well, that's the new moon. Well, that's the full moon that you can see with all of the sunlight on the moon. So now we're going to go into the phases of the moon, and we're going to talk about, because when you look at it, you've got one hole, if you would want to think about as the full moon, is 1. And then you're looking at the different quarters, right? So you can see half. So we're not going to take exact measurements on all of these, but we're going to just kind of take a look at some different fractions. So we'll go with 1/6, we'll go with 1/2, we'll go with 1/3, and we'll go with a whole 1. So think about these as different parts or phases of the moon that you're able to see at different points. And we want to put these in order from least to greatest. So it's nice that all the denominators are 1, and this one is also 1/1 if we wanted to write it like that, with the same numerators in all of these different problems. So we know that 1 whole is going to be our largest number, so we can put that one at the end. And that one we'll just cross out because that way we know we've used it. Then if you just kind of think, if we have a half, that is exactly 1/2 of something, so we know that's going to go in the middle between 1 and 0. But we don't have a 0, so we need to figure out which one of these is larger or smaller than 1/2, or if both of them go on one side of it. The 1/2 we used. We have 1/6 and 1/3. Now sometimes you can reason your way through it and go, well, 1/6 is pretty small. If I have 1/3 and I'm drawing something visually in my mind, if I even do something like this, I know I've got 1/3. But if I divided these again into sixths and only 1/6, I can see that that would be less than that 1/3. Another way to do it is to take like denominators. So we know that 3 and 6 will have a common denominator of 6. So we can turn this into a sixth. As Celeste said earlier, if we multiply the denominator by 2, we need to do the same thing to the numerator, which then gives us 2/6. If we have 1/6 and 2/6, and we're comparing those, we can easily see that 1/6 is smaller. Now we need to make sure, does 1/3 go here or in here? Well, if we have 2/6 and we turn this into a sixth, this will be 3/6. So we know that 2/6 will go here. So we have 1/6, 1/3, or 2/6, 1/2, and then finally 1. That, as messy as it might be, is one way to put all of those fractions in order. That is today's Math in the News, and who knows, you may be going to Alaska sometime soon, or one of the other countries, experience a little polar night, and you might even do it in the summer in the southern hemisphere and experiencing the same thing. That is today's Math in the News. We'll be back with more right after this.
Hi, I'm Olivia, and today I'm teaching you about long division. So first, there's 4 steps, and you can remember these 4 steps by using a mnemonic. A mnemonic is something that helps you with memory. So there's division, there's multiplication, there's subtraction, and then there's bring down. You can remember these by daddy, mother, sister, and brother. So let's do a problem like 573 divided by 9. We know 9 doesn't go into 5, so we put an X up there, and then 9 goes into 57 6 times, because that's 54, and that's as far as it can go into there without going over. And then we subtract that, which is 3. And then we'll bring down this 3. And we know 9 goes into 33 3 times, because that would be 27. And it can't go any higher without going over. Then that would be 6. And then there could be a remainder 6, a fraction, or a decimal. Today we're going to do a decimal. And you would add a decimal in the problem and a decimal here. You would add a 0 and bring it down, 60. And 9 goes into 60 6 times, being 54. That would be 6. And then we would bring down another 0, and that's a 0, so that would be 60. And then it would just keep on repeating, so it would be 63.66. You put a line on top to show that it keeps on going. That's a little bit of long division. Bye.
A little bit of long division.
That's right.
Funny how that
Just a little
came
bit.
out like that right there. 636-4357 is the phone number. Don't forget, you phone in to do the math today, tomorrow, or Tuesday, Wednesday of next week here in December. We will send you to holidaylights.com absolutely free for simply doing one of your math problems. In studio, we have Celeste, a 6th grade student from Panama Elementary. And speaking of dividing, you're going to do some right now, right? Mm-hmm. All right, head on over to the board. And Celeste, you'll be dividing fractions. So why don't you and Scott, you guys are going to come up with a fraction, and then you're going to explain everything to Scott. You ready? Take it away.
What do you want to start with?
Maybe 4/8.
4/8, okay. You want to have a fraction that you could divide, you could reduce first? You okay with that? All right, go ahead and write down 4/8. Good, and then we're going to divide this by something, right? So you can put a big division sign in the middle. There you go. Now the second fraction that we have, do you want that second fraction to be a proper fraction or an improper fraction?
Maybe proper.
Okay, proper, so that we know now that the top number is going to be smaller than the bottom, right?
Yes.
All right, we'll make a line here. What number are you going to use for this one?
2 and 7.
Sure, let's give it a shot. 2 and 7. Okay, it's interesting that you chose a proper fraction because you know what's going to happen next. We're going to have to flip it around anyway, right? So maybe
Yeah.
you were thinking one step ahead. What do we do from here when we see a division sign?
Well, first we could try by simplifying this.
Right, that's a good idea. And we talked about that at the very beginning when you chose 4/8. I asked you if you wanted to use a problem or a fraction that you could simplify first. That will save us probably a little bit of work near the end, right? So if you want to go ahead and reduce that or simplify that fraction first, that's a good idea.
4/8 would be 1/2.
Okay, how did you get that, by the way?
I would do 4/8. A number they might have in common is 2,
Okay,
and that'll give me 1/2.
so 4 divided by 2 is 2, right?
mean,
and 8 divided by 2 is 4. And then you can do it again, right?
Yeah.
Yeah, so if you can do it twice by 2 or you can do it once by 4, you get your 1/2. Let's go ahead and rewrite the problem again. You have this here, right, 1/2, but we're still going to divide it by, go ahead and put the other part. I got to keep that 2/7, right? All right, so what's next? Now we want to make this into a problem that we can do, and we know that when you're dividing fractions, it's nice to be able to change it to something else we already know how to do, which is multiply, right? Go ahead and explain what's going to happen there.
So we'd keep the 1/2 and
Yep.
bring it down here. And we want to switch this
Okay.
to multiplication.
Yeah.
And then we'd also want to switch this to 7 over
So when you say switch it, do you know a math term when you flip a fraction over like that?
flip.
You could flip it, right? So you told me about the denominator down here and the numerator up there. And when you flip a fraction over, it's a good word to know there. It's called the reciprocal, right?
Oh,
We're
yeah.
going to flip it over. So that's exactly what you do. You multiply times the reciprocal, which is exactly what's going to go on when you're going to multiply or divide fractions. All right, what's going to happen next?
And you got to times 7 by 1 would be 7.
Yeah.
And then you got to go across 2 times 2 would be 4.
Now we know when you add fractions, in order to do that, you have to have the same denominator, right?
Yeah.
What about when you multiply fractions like you're doing here? Do you have to have the same denominator?
No.
Okay, they just happen to be the same, right? That's kind
Yeah.
of convenient. All right, what do you want to do with 7/4? Because it's not quite in the form we
7/4,
wanted to be, right?
You want to simplify it.
Okay.
So you might, 4 can go into 7 one time,
Uh-huh.
which equals 4. And you might want to simplify 7 minus 4,
Gotcha.
which equals 3.
Gotcha. So let's go ahead and change this up just a little bit because you certainly have the right numbers. They're just a little bit goofed up in the wrong order, right? So we're going to go ahead and flip this around. And the reason is because when you have this fraction, we want to make sure that the fraction you're left over with also has the same denominator. We don't want to change that denominator. So before you do any math at all, what I like to remind my students of is just go ahead and keep that same denominator, the 4's on the bottom. What was the other number that you had there?
3.
It was, because 7 minus 4 is 3, right? So 1 3/4. Is there a way that you could quickly check to see if 1 3/4 really does equal 7/4?
You can times this.
Yeah,
You could times it by 4 equals 4.
yeah.
And then you could plus it by 3.
That's right. And it would still keep the same denominator, right?
Yeah,
So
so
that's a
it
great way to
equals
divide there. I like that. So we need to flip it over, use the reciprocal, and multiply. And then you end up simplifying at the end if you happen to have an improper fraction or a fraction that's not fully simplified.
Yes.
Great job. I like it.
Nicely done. So, came out with a mixed number right there.
Seemed to work out
1
well.
3/4.
Yep.
So, Celeste, do you like to eat ice cream?
Yes.
Do you have a favorite flavor?
I mostly like to eat chocolate.
You like chocolate. Would you eat chocolate with anything else mixed into it, possibly?
Depends on what it is.
Can you think of anything that you would put into it or that you have had mixed in with it?
Probably almonds.
All right, almonds. Have you ever had like a peanut butter mixed in with it also?
Not that I recall.
All right. What do you think is like one of the weirdest or oddest things you could mix into an ice cream?
Spaghetti.
Spaghetti. That is awesome. I would never even thought about spaghetti and mixing it in. Do you think if they had a spaghetti flavored ice cream, you would try it?
Nope.
No?
No.
Okay. Well, you know what? You've won yourself a free ice cream courtesy of Sweet Fix Creamery, and they have a lot of different types of flavors available. They have chocolate, but they have like a bunch of different types of chocolate, and then they have a variety of different flavors also, so you might be able to try one of those also. I don't think they have spaghetti. Maybe you can bring that up to them and see if they want to do that over at Sweet Fix. Anyway, we'll be back with more right after this. Well, checking out the reefs and the ocean and things like that all around Earth, time now to take a look at some math around the world. All right, in studio with us we have Harrison, and Harrison is a 6th grade student. And Harrison, you are going to tell us a little bit about some math around the world. What culture or where will you be telling us about this math from?
I will be telling you about Indian math. Well, they call it Vedic math.
All right, well, take it away. Let's hear all about it.
So I made this presentation. So first, I'll be talking about addition. And for adding, you go for the leftmost column, so the biggest one, and you add all those numbers up, and you just leave it aside. Then you go to the next column and do that until there's nothing left. Then you add all those numbers to get your final answer. And here's an example. Say 4,525 plus 3,756 plus 1,289 plus 504. So you would add 4,000, 300,000, and 1,000 to get 8,000. Then you do it with the next column, the hundreds, 500, 700, 200, and 500 to get 1,900. The tens, 20, 50, 80, and then 0 to get 150. And then 5, 6, 9, and 4 to get 34. And then you add those up, and your final answer is 10,084. For subtraction, they have this weird thing called bar numbers, and it's just the negative numbers. So you start at the rightmost and subtract, and if it's like 2 minus 5, let's say, you would make it a bar, and then you do it's just a negative number, let's say -3, it'd just be bar 3. So then you just do that and go to the very end. And there's a weird rule where every bar number for the first one on the right, you have to subtract it by 10, and there's that. And then the rest, it's by 9, and after there's no more bar numbers left, the next one, you turn it into its predecessor. So for this, if it's 750,236 minus 391,658, you do 6 minus the 8, which is a -2, so we put bar 2. 3 minus 5, -2, so you put a bar 2 again. 2 minus 6, -4, so you put a bar 4. 0 minus 1, -1, so you put a bar 1. And then 5 minus 9, -4, so you put a bar 4. 7 minus 3 is a 4, so you keep the 4. So then what you do is the rule where you have to take it and subtract it by 10. So you would do 2 minus 10 is 8, and then the rest by 9. So now 2 minus 9, which is 7, 4 minus 9, which is 5, wait.
You're good. You were saying, but
yeah,
you
I
said
was.
4 minus 9 instead of 9 minus 4, but we got you.
Yeah, and then 9 minus 1, 8, 9 minus 4, 5, and then you turn the last one into its predecessor since there's no more bar numbers, so 3. So 3, 5, 8, 5, 7, 8. And then the last one, multiplication, you do the tens if it's 2 digits. So you do the tens and you do those 2 and you just multiply them and put them on like the left side, just somewhere on your paper. Then you do the other column, the ones, and multiply those and leave a little space, but put them right next to it. And then you crisscross multiply and add the 2 crisscrosses together after you multiply them and put them right in the middle. And then you add it 2, 2, and there should be a leftover. You bring that one down and you have your answer. So For 17 times 23, you would do 1 times 2, which is 2. So you put it kind of like on the side somewhere on your paper. And then 7 times 3, which is 21, put it to the right of it, but leave a little space. And then you do the crisscross, so 3 times 1, 3, and then 2 times 7, 14, which equals 17 when you add them together. So then you would do 2 plus 1, which is 3, 7 plus 2, which is 9, and bring down the 1 to get 391.
That is awesome right there. So I know there's a lot of students that are probably going, you know, I kind of got a little bit lost because it was something brand new, but then the way you explained it and the examples that you had right there, especially with the multiplication one that we're looking at right there, simply taking it by chunks and doing it like that. So what made you decide, or what did you learn, you think, the most from studying this Vedic math from India?
Well, it's definitely more precise and quick, and yeah.
All right, so you found another way to do your math, right? Because we know there's a lot of different ways to multiply, correct?
Yes.
And you probably found another way, so now you probably, in your head, you probably got like, what, 18 different ways to multiply numbers? Anyway, Harrison, we certainly do appreciate you coming in and sharing your expertise on Vedic math today with a little bit of math around the world. Thank you very much, Harrison, on that. We'll be back with more right after this.
What is oceanography? The ocean holds about 97% of Earth's water and covers 70% of the planet. Scientists estimate the ocean was created 3.8 billion years ago, and it has played an important role in shaping the surface of Earth. There are a lot of different parts of the ocean we can study. To learn more about the different types of oceanography, let's ask Dr. Lisa Clow with the U.S. National Science Foundation. She's an oceanographer who has explored both the Arctic Ocean and the Southern Ocean around Antarctica.
Within that big mass of oceans, we actually do a lot of different kinds of science. There's physical oceanography. We think about how water moves around. There's biological oceanography, so all the living things that are in the ocean. And there's chemical oceanography, so paying attention to individual chemicals. And then we have geological oceanography that really deals with anything that's happening on the sea floor and down into the center of the Earth as well. So oceanography is many things. It's really a study of a particular part of the planet.
You may find this hard to believe, but we've only explored a tiny amount of the world's oceans. Some guesses are as little as 5%. The ocean is fascinating to explore and observe, but it is also important for all life on Earth. Did you know the oceans produce a lot of the air we breathe? Tiny plants in the water called phytoplankton create oxygen during photosynthesis. When you look up at the sky and see clouds, guess what? Oceans play a big role in making those clouds. They release water vapor into the air, and when it goes up, it forms clouds. These clouds bring rain and snow, helping plants grow and giving us water to drink. When you look at all the things the oceans do for us, it's kind of like it's Earth's heartbeat. The ocean causes changes in weather, influences the planet's climate, and helps support living organisms both in the water and on land. It also provides natural resources, promotes transportation and business, and makes our planet beautiful. It is our responsibility to learn about our ocean so we can understand how best to protect it and its many functions that are crucial for our planet's survival.
And a little bit more about our planet right there. 636-4357 is the phone number. Celeste, a 6th grade student from Panama Elementary, just digging 6th grade so far this year, correct?
Yes.
All right. So one thing I forgot to ask you was, how long have you been at Panama School?
About 7 years.
So you've been there for all of your schooling.
Yes.
So you're going to miss Panama probably a little bit when you leave, right?
Yeah.
You've been there for so long, right? It's like a home away from home. You've been there for most of your life. How old are you right now?
I am 11 right now.
And you've been there for 7 years. So you've been there for a long time.
Yes.
That's almost as long as Scott's been here to do the math, I think, right?
That's right.
Anyway, so you guys are working with a coordinate plane now. So Scott and you are going to go ahead and talk about coordinate planes and do a few problems, all right? Go to it.
Celeste, I'd love to get to this part of math because it incorporates one of your favorite subjects, which you told about us earlier, right? Which is art. You get to draw in math a little bit.
Yeah.
So usually what happens is your teacher may give you a piece of graph paper, right? Or you may see on a test that there's some graph paper, or maybe even on the computer. And a lot of times it'll already have a little graph drawn for us. So I'm going to go ahead and draw some axes, and then we can talk a little bit about what's going on here. So sometimes this will already be drawn for you, and sometimes it won't. But we're going to go ahead and draw one right in the middle. You notice that there's arrows on each end of each line, right? What that means is this graph really does go on forever, but we're not going to draw the whole thing because we'd be drawing for the rest of the day, right?
Yes.
Okay, so if we just looked at this line that goes back and forth here, right? That goes left and right, okay? If you had to guess, like you've seen a number line before, right? Mm-hmm. If you had to guess, which side are the positive numbers on? Are they on the right side or are they on the left side?
The right side.
They are, yeah. So we have some positive numbers over here, which means we have negative numbers over here. What about the axis that goes up and down? Are the positive numbers on the top of that axis or on the bottom?
The top.
They are, yeah. I mean, up means positive, right? And down means negative. So well, at least we know where some positive and negative numbers are, right? And sometimes graphs will be numbered by 2s or 5s or 10s. But in this case, we're just going to number them nice and easy. The first little line is 1, and then we have 2 and 3 and 4 and 5. And again, we could go on for quite a while, but I'll just do a couple of them. If you go in the other direction, you have -1, -2, -3, and these are negative numbers, just like you said. Up here, we're going to go 1, 2, 3, 4, 5. And one thing we want to be really sure of, we're not putting the numbers in the boxes. We're putting the numbers directly on the lines because the lines designate each individual number, okay? -1, -2, -3, -4, -5. Okay, so we have some numbers that are on our line here, right? We also have names specifically for these axes, okay? Do you know any of the names of the axes? They actually are letters. Do you know which letter goes on the axis that goes left and right?
The y-axis?
We have a y-axis and we have an x-axis, so you got 50-50 chance. So this one, we're going to look at this one first, right? Which one do you think that one is, x or y?
Y.
Try the other one.
X.
It is, that's right, well done, that's right. So what does that mean that this other one is up here?
X.
This is the y-axis, right? There you go. So the y-axis goes up and down, the x-axis goes left and right. Anything else at all that you know about graphing?
Well, sometimes it could be negative and a positive.
That's right. So we could have a couple positive numbers, we could have a couple negative numbers, or we could mix them up a little bit, right? How many spaces on this graph do these two axes divided up into, right? The x meets the y. How many kind of boxes or areas do we have in this picture?
4.
4, yeah, we have 4. And so if you had to number them, right, and we do have a way to number them, do you have any clue where we might want to start?
On the top left.
Yeah, we're going to start on the top for sure because that's positive, right? But we also want to start on the positive part of the other axis as well. So which part would that put us in?
On the top right.
Yeah, top right. So this over here, and there are 4 parts here. You talked about that a little bit, right? This is the first quadrant. Quad means 4. There's 4 of them right here, okay? And now we want to go to the next quadrant. We have 2 choices. We're probably not going to bounce over here, right? We have here and here. Notice I put it in a Roman numeral, by the way. You'll never see the number 1. You'll always see a Roman numeral there. Okay. Take a guess, an educated guess perhaps. Which of these quadrants is number 2?
That one?
That's a good guess. Well done. I like it. I wanted to make sure you were with me there. So if following this pattern here, right, we have a 2 in Roman numerals, where do you think number 3 is now?
Number 3 would be right there.
Yeah, so we're kind of going in counterclockwise direction, which is kind of odd because a lot of times when we're doing things in math, we're going to do it in clockwise direction, but we're going counterclockwise this time. Can you give me one more?
The fourth one.
How do you write 4 in Roman numerals?
I remember, but I forgot.
A little bit weird. We have an I and then we have a V, right? 1 before the 5. All right, so we have the names of these quadrants, and now we want to go ahead and put some points on here, right? We'll even go ahead and change colors. So let's see if you can tell me where we might find this point. 2, 4. The number 2 and the number 4.
Right here.
So how did you get there? Tell me about that a little bit.
Because my teacher uses a thing you want to walk before you climb.
Oh, I like it. It's a very good idea. I like that a lot. So you're going to walk back and forth on the level ground before you climb up and down the mountain.
Yes.
Yeah, I like that a lot. Something I tell my students is like an intersection for a car, right? Some of them are getting ready to drive, and I say, you're coming up this intersection here, and you get to the stop sign, right? And the first thing you do when you get to the stop sign, the first thing, look left and right. So that's the first number, right? We're gonna go left and right. Another way you can think of it is x comes before y, so we're gonna go ahead and do the x-axis first. All right, so you went over 2, and then you went up 4, and this point is 2, 4. That's a great way to do it. Let's do another one. We'll make this one green. How about the point -3, -1? Where is that point?
It would be right here.
Gotcha. How'd you get there?
I went to -3 and then I went down 1.
Gotcha. All right. So then when we put that point there, we always like to label that -3, -1. All right. I'm going to give you one more to challenge you a little bit. How about 7, -6? Now, by the way, these numbers are not labeled on this graph, but there is a place to put this point, right? Where are you going to go to for 7, -6?
7, -6 would be right here.
Okay. Tell me how you got there.
I went to 7 up here and then went down to 6.
Gotcha. So remember the very first one we're going to do, we want to go back and forth on the x-axis, right? So let's find 7. Tell me where 7 is on the x-axis.
Right here.
It is, that's right. So we want to go here first, right? This is 6 and this is 7. There's 7. And where's -6? Now that you're at 7, right? 1, 2, 3, 4, 5, 6, 7. Now that you're at 7, are you going to go up to -6 or down?
Down.
You're going to go down. Show me where -6 is.
Right here.
Yep. Can you go ahead and label that -6 right there? That's it. So now where do you think 7, -6 is?
Right here.
There you go. Can you label that for me just like I did right next to it? 7, -6. That's it. And every time that you graph one of these points, you did such a great job there. Where do you initially start? What is the original point that you start from every single time when we're trying to figure out where we start and then where we go to the numbers?
0.
Yeah, where is that?
0 would be right in the middle.
Right in the middle, that point right there, right? We're gonna make that one, what are we gonna do? We're gonna do blue. Right there in the middle. How would you write that point? In other words, if I was gonna do that in parentheses, how would you write that one?
0, 0.
That's it. That's a great way to do it. And just like when you were doing fractions, you had the denominator, you had the numerator, we had the reciprocal. There's a lot of good math vocabulary there, right? We have math vocabulary for graphing as well. We have quadrants, we talked about those, right? We also have a specific name for this individual point. Do you know what it is?
No.
Today's your lucky day because we get to talk about it a little bit. This is the origin because it is the original point. That's the way I think of it anyway, right? The original point right there in the middle and everything else goes from that position.
So
you can go
great stuff so far, but what
Yeah.
I'd like you to do is now I want you to simply plot a point,
and see if
and
you
I
can
want
identify
you
it.
to write down the ordered pair.
Oh, I like it. There you go.
So
Okay.
one final thing on that.
I like it. So we're going to go back to red here. Okay, I'm going to give you one more point. I'm going to put the dot, and then you next
And
to
I
it write
label.
down the parentheses, okay? Let's see here. Should I go way over here? No, I'm not going to go too far for you. How about we're going to go here and there, okay? I'm even going to give you some parentheses. What is this point here? And talk us through it about how you get the numbers that are going on there.
I think this is -7, 3.
Gotcha. Can you show me on the graph where you got to -7, right? So we have -5 here, right? Count backwards.
-6.
Good.
And -7.
That's it. And you put those right on the line. Good job. And then you went up to 3.
Yes.
Right? So a negative first and a positive next going to put us in the second quadrant. Yeah, good job there. I like that.
There you go. Well done. I'm so glad that you were able to do a little bit of work and learned quite a bit about coordinate planes, a little bit deeper in what you already knew. So as you do that later on in 6th grade, you'll be a little more familiar with it. Feeling good about that?
Yes.
All right. Well, so far we've learned quite a bit about the Earth today, and we're going to find out more with tectonic plates.
Space place. In a snap. Tectonic forces. There was once a time when you could take a stroll from North or South America to Africa, no problem. There was no ocean to get in the way, because all of Earth's continents were stuck together in one massive supercontinent called Pangaea. But around 180 million years ago, a rift began to form, and since then, the Americas and Africa have been drifting apart, forming the Atlantic Ocean in the process. Weird, right? Despite its rock-solid appearance, Earth's surface is constantly shifting and drifting. That's thanks to something called plate tectonics. Unlike other planets, Earth's crust isn't simply a single shell. It's got big slabs of crust called tectonic plates that float on an ocean of slowly flowing, rubbery, molten rock. These plates move because of heat from Earth's core. Earth's radioactive core generates an immense amount of heat that keeps our planet from completely cooling over. Less dense molten rock travels from the core to the surface, where it then cools and returns, a process called convection. Like a slowly moving conveyor belt, this rising and sinking heat and molten rock pushes or pulls the plates together or apart. Through collisions, these plates can raise great mountains or send ocean floor to the depths of Earth's molten interior. When they move apart, new crust is formed, and with it, entirely new oceans can be created. The formation of new ocean crust occurs at volcanic mid-ocean ridges. The destruction of old ocean floor happens in subduction zones. The creation and destruction of seafloor ultimately drives the gradual shift in the arrangement of continents on Earth. Scientists think that it could be possible to walk across a single Pangea-like continent once again, in just a couple 100 million years. Presented by NASA's Space Place.
And there we go, even more about the Earth. Celeste is a 6th grade student from Panama Elementary, has been at Panama for more than half your life.
Yeah.
7 out of the 11 years so far. Anyway, it always fascinates me. The kids are like, yeah, I'm not going to worry about missing it at all. Well, you've been there for a long time.
That's quite a
in
while.
many instances.
Yep.
And only natural that you would kind of miss something like that a little bit.
Right.
All right. So we're going to move on to something else that you're going to do during 6th grade year. And you're going to do a lot of these in 7th and 8th grade. You probably won't be able to count how many of these you're going to do in 7th grade. So we're going to get you ready for that. You all set? Yes. All right, Scott, here we go.
Okay.
5 plus 2, open parentheses, 6 minus 2x, close parentheses, plus 8.
Wow. We got a lot going on there.
A lot.
That's a lot happening. Okay, here's what we're going to do just to make it a little bit easier. Let's worry about this beginning part and this end part later on, okay? We're just going to look at the very first part. You have a number outside of the parentheses. Celeste, what does that say to you? What are you going to do with that?
Multiply it.
You are. What are you going to multiply together?
Multiply the 2 and the 6.
That's it. You got it. And this is called? You know what that's called?
Oh, distributed property.
Distributed property, right? You're going to distribute things. Like when you pass things out to everyone, you distribute the papers in class, right? Or you distribute the Chromebooks in class. You're going to distribute the 2 to everything that's in the parentheses. All right, let's do some multiplication. What's 2 times 6?
It's 12.
It is. What is 2 times negative 2?
Negative 4?
That's right. So you can go ahead and put a negative 4 right after that. Almost like a minus 4.
Yeah.
And then we also have this letter in there, right? The letter doesn't mean xylophones. It means some other value we don't really know. So you can go ahead and stick an x at the very end there, right? So what we did multiply actually is 2 times negative 2x.
Yeah.
Okay? Now we're going to put things back that used to be there, like I was saying before. We're not forgetting about them. We were just kind of not worried about them for a minute. There's going to be 5 plus this, and at the end we're going to have plus 8. Now the next thing you want to do with something like this, with all kinds of letters and numbers, we want to put things together that go together. Okay, I want to combine like terms to simplify this as much as possible. Just like you simplified the fraction at the beginning of the other problem, we want to make this as simple as possible. What numbers look like they might go together?
4 and 8.
4 and 8. Oh, tell me why.
Well, like earlier, they have 2 in common.
They do. This is true. Good point. The only difference here is this 4 is connected to the x. So we could think of it like 4 xylophones, or 4 corn dogs, or 4 skateboards, or whatever it happens to be. Can you mix that with the number 8? You can't really put them together, right? You put like 4 skateboards and $8 in a box and you mix them all up, you still got 4 skateboards and $8, right? So you can't really put them together. What numbers could you put together?
Oh, 5 and 12.
Yeah, you could put 5 and 12 together, absolutely. So these numbers will go together. Why don't we go ahead and put those ones together? Then we don't have as many numbers to look at, right? What's 5 plus 12?
17.
Okay. So you can do your 17. Go ahead after that, continue to write negative 4x plus 8, because those things didn't go away. All right, tell me what other numbers you might be able to put together so that we can make this as simple as possible. We can't really combine this part with the 8 because they don't really go together, right? This has an X, that one doesn't,
Yeah.
right? This one has an X, this one doesn't. Can you put those together?
No.
Not so much. What can you put together though?
The 17 and the 8.
I like it. So now we're rolling here. We can put this one together with that one. I like to use these big old arrows. Let's put those together. What's 17 plus 8?
25.
25. Nothing wrong with using some fingers there, huh? Don't forget the negative 4x. You're going to put that afterwards, okay? So we put things together that go together, and you have simplified the best you can the expression that happened here. This is a lot easier to read than all this crazy stuff up there, right? Now, sometimes when you see this answer or you get to the end of a problem like this, and this is a multiple choice problem, and they say, which of these final answers is the right one? It may not be written like this. And here's why. Sometimes when they write the answer to one of these problems where you have an expression that's simplified at the end, they will put the X part or the number with the letter next to it, the number with a variable, they'll put that part first, okay?
Yeah,
So you may see this like this. Negative 4x, we're keeping the sign. Is the 25 positive or negative?
Positive.
It is positive. So you may see the answer like this. These two numbers, there's my 25. These two expressions are completely identical. There's nothing wrong with switching things around as long as we kept the signs.
Yeah.
So you may see it like this. The answer you have here is also correct.
And
Go to
since
look
you
at it.
did so well with that, I've got a bonus problem for
Bonus.
you right now. All
There we
right,
go.
clear the screen. All right, 3,
3,
open parentheses, 2x plus 5, close parentheses, minus 2x.
Okay, Celeste, I think you might be on your own on this one. Let's see what you can do with this one. Talk me through it. Tell me what you want to do.
With this one, we could do the distributive property.
Okay?
So this would be a 6 times,
So tell me a little bit about the 6. What happened there?
we times
Good.
3 times
Yeah,
2
3
and
times
leave the
2.
6.
Good for you. Got the 6x.
And then times plus 5.
So we have a plus. Certainly got to bring that one down. I like that. Don't forget this 3 is being multiplied here, and it's also being multiplied there.
So it'll be 15.
Right. 3 times 5 is 15. Good. What else is left over that we don't want to forget about?
The 2.
Yeah, go ahead and write that
negative
again. Good job. I like how you did that. So far, so what we've done here, which is kind of a neat thing, you made something that looks a little bit complicated with all these parentheses.
And
You
we
made it a little
break
bit
it down.
simpler. Yeah. As soon as you use that distributed property, the parentheses go away, which is nice. Okay, what things go together?
The 6 and the 15.
Okay, tell me about that. Why did the 6 and the 15 go together?
Because they don't have the x attached to it and it's not a negative.
There you go. So the 6 has an x attached to it, but the 15 doesn't have an x attached to it, right?
Yeah.
So we can't put those together. Which ones can we put together?
The 6x and the 2x.
There you go. Those ones specifically have x's, don't they? Right? So we can put those together. Go ahead and do that. What do you got? I'm going to turn you to green. Here we go.
Wait, do I multiply or plus it?
Well, let's see. What does it say?
Oh,
You have 6x, and then we have
The 2x.
minus 2x, right? It has a
Minus
negative
2x.
sign. So don't look at that part. It's almost like if we rewrote it. So one way you could rewrite this is you could say 6x minus 2x plus 15. There's nothing wrong with switching those two things around. Now we can see that we have two things you can put together, right? Mm-hmm. Okay, go ahead. So what's 6x minus 2x?
That'll be negative 4x.
Not quite. I like the 4, but it's just like having six skateboards minus 2 skateboards. Right?
Yeah.
You just have 4.
So we won't have this one.
Right, so you can go ahead and erase that one. Whoa, we went all crazy on that one. I like it. Here we go. I like to use the back part of my hand. It eventually erases. There we go. Sometimes you make a new mark. Okay, so you got the 4. Don't forget the x part.
4x
And then what else is left?
plus the 15.
Now, is this the form that we like to have it in? Is this the form that you might see on a test?
Yes.
With the letter first? It is. If you were going to write it the other way, right? If you were going to move it back around, what would it look like?
It'll look like 15 plus 4x.
And are those the same?
Yes.
They really are, right? They look a little
just
different if you
switched
switch
them
them around, but we kept the signs, right? The 4 really is positive, and you kept it positive. The 15 is positive. We kept it positive in the front, even though we didn't write it. Good job on that one. I like it.
Nicely
Do we have a
done.
bonus problem?
There you go. Come on over here, Celeste. That was some great work. And when you start doing those in 6th grade a little bit more, hopefully you kind of remember what you and Scott did right there, and it'll kind of come to your mind and go, oh yeah, I remember. He was showing me how to do that stuff right there. So you are now an ambassador for Do the Math. Do you know what that means?
I've been here.
You've been here. That doesn't mean you've been here. You are an ambassador because that's the only way you can be an ambassador is by being here. But now that you are an ambassador, do you know what that means to be an ambassador?
No.
Okay, so you're going to let people know about Do the Math. Can you do that?
Yes.
That's a pretty easy thing, isn't it, right?
Yeah.
We gave you a uniform. You remember that shirt that we gave you?
Yes.
Like a high quality shirt right there, you know. So every time you wear that uniform, I want you to tell people about Do the Math because they're going to go, hey, Celeste, what is up with that shirt right there? And you're going to tell them about the Do the Math show, right? All right. Now, one of the things that you'll be receiving today is one of these. Do you have any idea what that is?
A Rubik's Cube?
A Rubik's Cube. Do you master those? Do you know how to do those?
No.
No? Well, you know what? Scott's a master of the Rubik's Cube. Hey, he's about as masterful at it as I am, and I'm sure all three of us together would probably take some time figuring it out.
That's right.
But this is a limited edition Do the Math Rubik's Cube.
Very nice.
So even though you might know some other people with Rubik's Cubes, you as an ambassador will be one of the
Have the
few
one.
that has the Do the Math Rubik's Cube right there, all right? So you can do me a favor, you be an ambassador for Do the Math?
Yes.
All right, good. So one other thing that's coming up is you heard that we are giving away Holiday Lights at COM tickets, and that is for any students that phone in tomorrow, Wednesday, as well as next Tuesday and Wednesday. Those are the only 3 days that you're going to be able to call in to Do the Math to get yourself free tickets to Holiday Lights at COM. One of the great features that a lot of kids and adults as well love when they go out there is taking a ride on the train. So tomorrow we're going to have, I know it's not, is it Engineer Steve or? Engineer Steve, he's going to be in, and I know he's quite proud of it. Very, very involved with COM and everything that goes out there, and very hands-on. And if you want to know anything about the train, we're going to have the engineer here tomorrow. We're also going to be talking about some floral arranging and making some wreaths and floral arrangements, and that stuff will be going on out of COM as well. And the House of Flowers is going to be here, so we'll have somebody here talking to us about floral arranging and making wreaths. And once again, don't forget, Holiday Lights tickets will be available tomorrow on Do the Math, as well as next Tuesday and Wednesday. Have you ever been to Holiday Lights?
No, I don't think so.
Okay, well, you know what? Maybe you have an opportunity, because lights are always fun to look at and stuff like that, right? Have you ever been to Holiday Lights?
It's a pretty neat place, no doubt.
Yeah, indeed it is. So there's a lot of things going on, and we will have all of the people with all of the answers here tomorrow. Did you learn a little something today?
Yes.
Good. I'm glad to hear that. Did you have fun today?
Yes.
That's the most important thing right there. Our newest ambassador, Celeste, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.